So first of all, a very warm good evening to all of you. I just hope you all are doing great, and please stay hale and hearty, take due precautions, and if you are at your home, please don't take that stay for granted, because accidents are called accidents because they happen accidentally. So don't give any chance to the virus. That's all I can say. Take due precautions. Now coming to this topic, by now you would have seen the title of this video, which says the construction or basically the working of electric motors. So in this lecture we will focus on the working of electric motors. Okay, so just imagine when you switch on your fan, the moment you press the on button, the fan starts to rotate. So just imagine you are switching on the switch, you are putting the switch in the on mode, there is flow of electrons, the electrons are flowing, and then suddenly that fan starts to rotate. How that electron is able to rotate that huge fan, that should surprise you. So in this class we'll try to find the answer, that how this flow of electrons, how this flow is responsible for the rotation of fan. So for that, in the last class I have defined what is an electric motor. So electric motor is nothing but where your input is electrical energy, you give electric energy, and then it converts into mechanical energy. So this will be your output and this is your input. Okay, so this is the function of electric motor. Okay, so the first concept, while describing this working of electric motor, so let's draw this. Okay, so in electric motor you will always find magnets. Now in this magnet, in the last class we have already discussed that if you put a conductor in this magnet, in this magnetic field, and it is a current carrying conductor, then it will experience a force. It will, if you place an current carrying conductor in this magnetic field, it will experience a force. And this funda is used, this funda is responsible for the working of electric motors. Okay, so let's start directly how a motor works. So suppose you are having this poles are there, and then there is magnetic field is there from north to south poles, and suppose there is a rectangular section, this is your rectangular current carrying conductor, this is a current carrying conductor which have this cross section. Okay, so the current is coming from here, it is flowing like this, it is flowing like this, and then it is coming out. Okay, so suppose this is your initial arrangement. You are taking a current carrying conductor whose cross section is rectangular, and this is the direction of flow of current, and it is being put into this magnetic field. Okay, so in the last lecture we have also discussed about Fleming's left hand rule. We have already discussed about Fleming's left hand rule. Okay, so what does this rule says? I hope you all remember the last lecture, FBI. If you put your left hand like this, perpendicular to each other, then this this forefinger will be representing the direction of magnetic field. This will represent the direction of magnetic field. This will be in the direction of current. And if you put it like this, the thumb will represent the direction in which the Lorentz force or the force is being exerted. So FBI. Okay, so now suppose this is your arrangement. Okay, so now I just want to see, now remember one thing, in this part of conductor, the force will be in some XYZ direction, in some direction. Now again the orientation of conductor is changing, so here the force will be in some other direction. Now again if you come to this part, again the direction of current is changing, so the direction of force will also change. So now let's try to find out in which direction all the forces are working. Okay, now this is our job, and your answer lies into this, that how, just by conducting your magnetic field, just by having a current, how you can rotate this. And if this gets rotated, you can connect something to this, a fan to it, and fan will also rotate. So if this arrangement starts to rotate, then whatever you attach to it, that will also rotate. Okay, so now let's see how it rotates. Now first of all, let's consider this part. Okay, now in this part, if you see, current carrying conductor is there, current is there, magnetic field is there. So now let's apply left hand rule and find out in which direction force is there. So it is going like this. So FBI, so B is like this, I is like this. Are you getting my point? Current is in this direction, current is in this direction. Magnetic field is in this direction, magnetic field is in this direction. So the force will be in upward direction. Okay. So now in section, suppose I am dividing it A, B, C, D. Now in section A, B, the force is in upward direction. I hope it's clear to you. You can do by yourself. Okay. Now let's consider this section CD. Okay, let's apply left hand rule here. Now suppose I am applying it like this. See, suppose this is the magnetic field. So magnetic field is in this direction, but current is in this direction. Now I am sure you are able to see somewhat. So now when your magnetic field is in this direction, current is in this direction, so the thumb will be in bottom direction. Okay, you can do it by yourself if you are finding it difficult to see. So when your magnetic field is in this direction, the current is in this direction, so the force will be in downward direction. Okay, so in section CD, the force is in downward direction. Okay, so now let's consider this portion and this portion. Now again, if you go to class 12th, you will get one funda, that if your magnetic field, if the direction of magnetic field and current are parallel, if your magnetic field and current, they are flowing parallel to each other, then the magnitude of force will be 0. Now don't be surprised, you would have read this in class 8, 9, 10, 11, 12. You know, at least twice or thrice you would have read this. When your magnetic field and current, they are flowing parallel to each other, then they won't be exerting any force on each other. So in this direction and in this direction, you can see that the current is in this direction, magnetic field is in this direction. Although they are opposite to each other, but if you keep it straight, they are parallel to each other. So therefore here BC section, in the section BC, F is equal to 0. In section AD, this portion AD, again the force is equal to 0. Now this you need to remember. Ab aap practically sochiye, you think practically. Now for example, you take, I'll give you one, I'll take one rectangular section. क्या लूँ, ले सकते हैं. Okay, yeah, this is there. Okay, fine. So this Clinique plus sachet is there. So what you can say is that, now just imagine this in this form. Now at this edge, on this edge, F is equal to 0. On this edge, F is equal to 0. On this edge, force is in upward direction. On this edge, force is in downward direction. So what will happen? Ultimately, it will rotate like this. Got it? I hope this is clear to you. So just by providing electricity in the magnetic field, we are able to rotate it like this. Okay. Now everything is good. It is rotating like this. But once it goes into this position, then what will happen? Initially it was like this, then it became like this. Now what will happen? Now this is a very tricky question. If this orientation happens, then what will happen? Now I'll discuss again. Okay, now just have patience. Let me draw the diagram. Suppose your new orientation is that, because see, initially it was like this, it moved. So it moved like this. But once it comes into position like this. Okay, now in this case, suppose here the current was in upward direction. Now once it goes like this, again the current will be in upward direction. So again the current will be in upward direction, and here the current was in downward direction. Now when you move it like this, the current will, because so, see, same edge is there. Same edge is coming to this part. So the current will be in downward direction. So here the current will be in downward direction. So in this way it will flow. Now you tell me, the current is in upward direction. So again you apply FBI here. Nothing has changed. Again the force will be in upward direction. Here the force will be in downward direction. So what will happen? It can come back. It will come back to the original position. So mind it, it will not rotate completely. It will be like this. It will go like this. And then again it is, see, here it was in upward direction. So it went like this. But after coming here, again the force is in upward direction. So it will come back to here. So it will go like this, like this, like this, like this, like this. So this fan will rotate in this manner. Okay, but now here the trick lies. हमारा फैन क्या सच में ऐसे काम करता है? Our fan rotates like this, 1 2 3 4 1 2 3 4, like this it happens? No, it is continuous rotational motion. So how can you do that? Now you tell me. Here the force was in upward direction, after coming here again it was in upward direction. But suppose if I change the orientation of this force, if this force becomes in downward direction and if this force becomes in upward direction, suppose it came like this, and if I somehow am able to change the direction of force, then again it will rotate, and so it will complete a rotation. I hope you are, see, you can have a little bit of confusion, so my only request to you is that if you have any confusion, draw the diagram and try to find the rotation by yourself. You know, do it as a homework. You will realize it कि initially it was in this portion was in, again I am telling, see, my habit is to repeat again and again so that it impinges in your mind and you will never forget in your life. At this point the force was in upward direction. When it went like this, again the force was in upward direction because nothing has changed. Magnetic field direction is same, current direction is same. Current, when it was like this, current was in this side. When it became like this, again the current is in this direction. So if here the force is in upward direction, once it goes here, again the force will be in upward direction only. So it will go like this and then upward direction, here downward direction, again it will come back. So it will happen like this. So you can complete the rotation once if the force is in upward direction. Once it goes like this, it should be in downward direction. Then it comes like this, again it should be in upward direction. So if you are able to change the direction of the force, then only you will be able to complete the rotation. Okay, now I hope this is clear to you. Now how to change the direction of force? Now see, if the current is like this, the force is in upward direction. Now one option is you change the orientation of the this poles. If you make, see, initially you do as north here, south here. After half rotation you make this as south and you make this as north. So when the orientation of magnetic field changed, the direction of force will become downwards. Okay, so one option is to change the orientation of the magnetic field, to change the direction of the magnetic field. Okay, but this option is not possible. It is not practically possible. It is not practiced in our fan. So in our fan what happens? Either you change the direction of electric field or you change the direction of current. Okay, so the second and the usable practical option is you change the direction of the current. Now just imagine if, see, initially now yeah, so this is your direction. Okay, now if initially it was here and then after going here, if the direction of current is same. Now if I change this direction to this direction, then what will happen? Just apply Fleming's left hand rule here, the force will be in downward direction. And if you change this direction from this to this, then the force will be in upward direction. So it will again rotate. Okay, so in this way it can rotate. Now one question should come into your mind that, sir, initially you said that, sir, since this and this are parallel to each other, so they will have zero force. Okay, but once it becomes like this, suppose the orientation is, suppose if it is like this and field is like this, magnetic field is like this, it is parallel. But once it becomes like this, if you just make it slightly slant, then they are not parallel. They are not parallel. Then what will happen? You just apply Fleming's left hand rule here. Suppose this is like this, or even if it is like this, or even if it is like this, if you apply Fleming's left hand rule, you will find that the force is in outward direction. In this, if you apply, see, it is the current is in this direction, you make it. Now current is in this direction, magnetic field is in this direction. If you apply, the force will be in outward direction. So here the force will be in this direction and here the force will be in this direction. Now, sir, you are telling that because of the change in orientation of these forces, the fan is rotating. But what about these two forces? Now just look at this. If I am stretching it here, if I am applying the force here, and if I am applying the force here, is it going to affect your sachet? Is it going to affect your fan? No. So these two forces will have no effect. You know, if their magnitude of force is exceptionally high, in that case they can just push, plunge it off. But for that, the quantum of force, the magnitude of force should be exceptionally high. But that is not the case. So these two forces in this direction and in this direction, they are like negligible. They are not considered. So basically we will focus on these two edges. Okay. So now it will rotate. Okay. Now, next thing. I told you that you need to change the direction of current. but is it so easy? See, if you put a wire, now if you complete the circuit, plus minus, suppose here it will minus will be there. Now here you are doing that current is going like this. Now if you want to change the direction of current, you have to suddenly change the biasing of the battery. You have to change the biasing of the battery. Suppose this is positive, you have to make it negative. And moreover, see, if this is there, you are attaching a wire over here. If you do it like this, the wire will see, the wire will indulge, the wire will get engulfed into each other. So that is also not practically possible. So what is the system? How do you change the orientation of the current every time? This question should come into your mind. So for that, I'll give you one answer. The answer to this question is the use of commutator. इस टॉपिक को पढ़ाने में मजा क्लास में आता, because in the class you can demonstrate things. Here I am finding it pretty difficult because I have to manage a lot of things. But anyways, so commutator. Now what is commutator? It is having this kind of orientation. Commutator is something which is having this kind of structure. Okay, so it's like semicircular ring is there, and in that you have brushes are attached. Okay, so this is known as your split rings, and they are always put at some gap is always there. Here the gap is always there. So this is a split ring, and this split ring is metallic. Now when I say metallic, it means they are very good conductor of electricity. That's why I'm mentioning it is metallic. And this is known as, these two things are known as carbon brushes. Now what is important, this carbon brush and this arrangement, this split ring, they are not attached, they just touch each other. This carbon brush and this split ring, they are just touching each other, they are not attached. So when I say that this will rotate, this will not rotate, this will be at its place, but this will rotate. Okay, so now what will happen? Now I'll again draw the diagram. So this is your south pole, this is your north pole, this is your current carrying conductor, suppose. And then if you come here it will be suppose attached to this split ring, carbon brush, split ring, carbon brush, and then you will have a circuit. Okay, so now once you start giving the current, once the current is made on, once the current starts to flow, then what will happen? See, initially it is flowing. See, this commutator 1 and commutator 2, this commutator is carrying the current in this direction, but once this rotates, this switch, this split ring will come into this side. It's like this is the commutator. Just please look it carefully. So this is your commutator. Now once the fan rotates, they will also rotate and they will change like this. I hope now it's clear to you. So the same commutator which was supplying current in this direction, once it rotates and it's come here, it will supply the current in this direction. Okay, so that's why you are able to change the direction of the current. I hope it's clear to you. See, again I'm telling you, just imagine these two are there, just these two, imagine these two to be these two. So it is like this. Okay, so the current is flowing in this direction, and this is the positive one, it is connected to the positive terminal initially. Okay, and this is connected to the negative terminal, but once, and moreover, the current is being supplied to this commutator with the help of this brush, and this brush is static. Remember, this brush is static, but this commutator is movable. Okay, so what happens, once this fan rotates, the commutator will rotate. Okay, now initially the commutator was giving the current in this direction, यानी इस वायर को ये commutator इस डायरेक्शन में करंट दे रहा था. But once the rotation happens, the same wire will come here, and the commutator will join to this brush and it will give the current in this direction. And again this will happen, this commutator will again come here, it will give the current in this direction. So gradually as the commutator moves, the current direction will change. Okay, so ये हो गया आपका commutator का function, and this is how your orientation of current, direction of current changes, and that's why commutator is one of the most important part in motor. ओके यार ये तो हालत खराब हो गई बोलने में. आई होप आप सबको समझ में आ गया हो, क्योंकि यार इतने छोटे से अरेंजमेंट में समझाने में बहुत मुश्किल काम होता है. सो अगर आपको कोई भी डाउट हो, यू कैन आस्क मी एनी टाइम, एंड इफ यू विश देन वंस द क्लास रीओपन्स वी कैन डिस्कस इट अगेन. दैट्स नॉट अ बिग डील. ओके, सो नाउ दिस इज हाउ योर इलेक्ट्रिक मोटर वर्क्स. अब आप इस अरेंजमेंट के साथ एक फैन लगा दीजिए, ये घूमेगा, फैन भी घूमेगा. ओके, सो नाउ आई होप दिस इज क्लियर टू यू, whether you are from civil department, biotech department, CS department. But from now onwards you may not know the intrinsic mechanism of fans, but at least you all should know how a fan works. So this is how a fan works. How a fan works? करंट करेंट कंडक्टर लिया, उसको एक मैग्नेटिक फील्ड में रख दिया, करंट कंडक्टर पे फोर्स लगा, फोर्स लगने से वो घूम गया, और अगली बार जैसे ही घूमने का फोर्स उल्टा करने लगा, मैंने क्या किया, फोर्स का डायरेक्शन ही चेंज कर दिया, तो वो और घूम गया. And for that you need commutator to change the orientation or direction of the current. Okay, so now I hope this is clear to you. Now for today, the last thing is the advantages and disadvantages of motor. Now as far as application is concerned, in the last class we have discussed about the applications. Okay, and there are several applications, whether it is fan, electric vehicles, blowers, pumps, heating systems. So there are several applications of pumps. Okay, now what are the advantages? First let's discuss the advantages. So the first advantage is that its cost is low. Okay, nowadays you can see that everywhere motor is used for pumping water, for fan, and everywhere you can see the motor around yourself. So the first advantage is that it is less costly. Okay, second thing, it does not use fossil fuel. Fossil fuel is not used in its operation. That is the second advantage. The third advantage is that it requires little maintenance. Now you can see that here, liquid thing or fossil fuel burning, these things does not happen. It is simply electric wiring circuit, metallic bodies there, non-metallic bodies there, so it requires very little maintenance. The fourth advantage is that again it does not consume fuel. Okay, now the fourth advantage is that its lifespan. Now again you can see little maintenance is there, so obviously its lifespan will be high. Okay, so these are a few advantages. Now as far as disadvantages are concerned, the first it has only one or two disadvantages. First of all, the disadvantage is that sometimes the motor can be very heavy, large size या फिर heavy. Have you ever seen motor? Even if this big motor is there, it is not easy to lift it because it's like fully metallic body, so it is not easy to lift it. So it can be of large size, it can be of heavy. Second thing, the voltage and current combination, they have to be optimum. If there is slight differences, if there is slight problem in this voltage supply or current supply, or if there is some problem in the connection, the motor will not work. So that VI thing, the voltage and current thing, that has to be always optimum, and that has to be always checked. Okay, now the third thing, expensive line expansion. Now this expensive line expansion is important, especially in those areas where things are not very easily available. Suppose if you go to interiors of northeastern regions, if you go to interiors of Uttarakhand, then there the infrastructure is not that good. So if you want to have electrical connection over there, because see, electric motor runs because you need electric connection for it, and if you want to establish an electric connection, then it means you need to have a power plant, you need to have a transmission line, everything you need to have, and that can be expensive, especially in interior area. So this is one more disadvantage. Okay, so now I hope in today's class these things are clear to you, and if you have any doubt, again I am telling you, please call me, message me, email me, disturb me whenever you want. Please bother me, don't hesitate. Okay, and please do good care of yourself. Okay, so in the next class we will discuss the other aspects of electric motor. Thank you.